today we are starting a new module. We are doing module 4, which is all about linear equations. It's all about equations. So who can tell me if I have the equation, let me put a page before this so we can see something. So if I have an equation of 6 plus 3m equals 12. If that is my equation on the board. Who can tell me what do we call the 6 and the 12? They have specific names. What do we call the 6 and the 12? They're by themselves. They have nothing with them. What do we call them? Let's think back to our vocabulary. I want you to turn to your neighbor, to your partner, and I want you to have a discussion. So I'm going to be your partner today. So what do you think? Alright, anyone come up with the name of what we call that 6 and that 12? No one, so we can't remember that far back from last year. So let's refresh our memory. The 6 and the 12 are called constants. And they are called constants because they are by themselves. They have no variable attached to them. They are by themselves. They are a number without a variable. A constant is a number without a variable. What did I just hint for you to do? A constant is a number without a variable. So we have another term in there. Remember, a term are things separated by operation signs. Terms are pieces of the equation separated by operation signs. Everyone right now should have out their 5-subject notebook. Everyone should be writing things down. A term are pieces of the equation separated by operation signs. Pieces of the equation separated by operation signs, terms. So we have another term in there. We have the term 3m. 3m. Of course, what is m? What do we call m? What? A variable. So a variable is a letter that stands for a number. A variable, of course, is a letter that stands for a number. And when we choose variables, we can choose any lowercase variable. But please do not choose O and do not choose L. What does an O look like? 0. What does the L look like? A lowercase L looks like a 1. So we don't use those two. All right. So we have that variable there. And then we have that 3. That 3 that is attached to that variable, that's married to that variable. The number that is hooked, linked, married, whatever you want to call it. But that number that is with the variable, what do we call it? What? Coefficient. Very good. A coefficient is the number attached to the variable. It is the number attached to the variable. The coefficient is the number attached to the variable. So these are pieces of our equation that come together to form that equation. So if we take a look at our first one, and it starts off right away, and it says, I want you to write equations that take these words and put them into numbers, put them into an algebraic sentence. An algebraic sentence includes numbers, variables, equal signs, and operation signs. So if I were looking at this, and I read that first one where it says the sum of 4 consecutive integers is negative 28. The sum of 4 consecutive integers is negative 28. So I think to myself, okay, in my head I'm going, okay, well sum, that means plus, 4 consecutive even integers. Oh my goodness. So I need to think to myself, what are 4 consecutive even integers? What does that term mean? Well, that means I'm going to have 4 numbers, right? 1, 2, 3, 4. 4 integers, 4 numbers. Remember, they have to be whole numbers. They say integers. That means no decimals, no fractions. Integers, whole numbers, positive or negative. All right? And the sum of them is negative 28. So I know I'm going to add 4 things up, and I'm going to get negative 28. But let me address that term, consecutive even integers. So in my head, I'm thinking consecutive. Consecutive means one after another. Consecutive is one after another, like 1, 2, 3, 4, 5. Those are consecutive numbers. Okay, A, B, C, D, E. Those are consecutive letters. They come after one another. They come in order. So consecutive even integers. So if I start with the number 2, the next even integer that's after this is 4. Then we have 6. Then we have 8. So in my brain, I know that 2, 4, 6, 8 are 4 consecutive even integers. But I don't know what my first one is. So if I replace the first integer with the letter x, and I say instead of 2, I'm going to put x. Now, to get to my next consecutive even integer, to get to that next consecutive even integer, to go from 2 to 4, what do I add to 2 to give me 4? 2. So I'm going to, instead of writing 4, I'm going to put x plus 2. Now, my next consecutive even integer is 6. So that means I'm going to start with x, and how do I go from x to 6? I add 4. Then, if I were to have 8, if I were talking about that 4th consecutive even integer, that is 8, I'm going to start with x, which is 2. To go from 2 to 8, I add 6. So now I have this equation that I wrote. And so if I were to sum that up, I have x plus 2 plus x plus 4 plus x plus 6 equals negative 28. Now I want to simplify my equation. So we need to remember, what does simplify mean? Simplify means to combine my like terms. Combine my like terms. So here's another definition, another terminology that we need to remember. Another term. Simplify like terms. What is a like term? Well, a like term are variables raised to the same power. Same variables raised to the same power, or constants. Same variables raised to the same power, those are like each other, or constants, because constants are like each other. So in this case, I've got some variables. I have the variable x. They're all raised to the power of 1, because I do not have any other power there, so they are raised to the power of 1. So I have 1, 2, 3, 4 x's. Then I have some constants that are alike. I have 2, 4, and 6. So 2 plus 4 is 6, plus another 6 gives me 12. And their sum is negative 28. So now I rewrote that thing in words, that statement in words, and I wrote it as an algebraic equation.
How do you do the 4 again?
How many x's do I have? I have 1, 2, 3, 4 x's. 4x. It didn't ask me to solve. It's just asking me simply to write it. So I'm going to clear this so that I can rewrite this nice and pretty, make it all good. So let's see. We have 4x plus 12 equals negative 28. So now I want to look at number 2. Number 2 says a number is 4 times larger than the square of half the number. The number is 4 times larger than the square of half the number. Give me a second. It's in her. It's in the.
Wait, when you charge it,
I told Ashley. I put it in the. Cindy had already left. I didn't want to go home with it. It's in her tray. Okay. Outside her door. Thanks. All right. So number 2 says a number is 4 times larger than the square of half the number. So a number. I want to represent a number. I can use any variable I want. I'm going to use x. A number is 4 times larger. So that is, the number is. That word is very important because the word is means equal. So a number is 4 times larger than the square of half the number. The square. How do I write a variable squared? Well, that's simply just x squared. But the square of half the number. So I'm going to take the number, cut it in half, and square it. So a number is 4 times larger than the square of half the number. So I cut the number in half, square it, multiply it times 4. 4 times. It tells me exactly what to do in that equation. So if now I look at the next one. So if I look at the next one, if I look at number 3, Stephen has some money. If he spends $9, he will have 5/3 of the amount he started with. He has some money. He spends $9. When he spends the $9, he will have 3/5 the amount he started with. 3/5 of that number is the same as that number minus 9. He spent $9 of that money, and that leaves him with 3/5 of the amount he started with. He spends $9, it leaves him with 3/5 the amount he started with. Now, number 4, let's try to do this one together. Number 4 says the sum of a number squared is 3 less than twice the number is 129. Right, so you guys tell me, what can I use to represent the number? What? X. X sounds great to me. So when I say the sum, what is that telling me the operation I'm going to do? Add. I'm going to add. So the sum of a number squared, how do I write that number squared? X squared, all right? And, so I'm going to add the sum of a number squared and 3 less than twice the number. How am I going to write 3 less than twice the number? 3 less than twice the number. The word than has a very special meaning. The word than says that whatever comes behind it and whatever comes in front of it, swap places. Whatever comes after than and before than swaps places. So it says less than, so Robert was correct when he said subtract. So let's take up this little portion. Well, 3 is basically what? 3. Thank you. That wasn't a trick question. Less than twice the number. How do I show twice the number? What? Multiply. So what am I multiplying? X times 2. So we're going to say 2x. So being I have the word than in there, that word than says these two things swap places. So 2x minus 3. Is, of course, what do we say is meant? Equals 129. So this is our equation. X squared plus 2x minus 3 equals 129. All right. So let's look at number 5. Miriam read a book with an unknown number of pages. The first week, so an unknown number of pages. So how am I going to represent an unknown number of pages? A variable, so I can use x. I love x. With an unknown number of pages. So the first week, she read 5 less than 1/3 of the pages. 5 less than. 5 minus, that word than is important, 1/3 of, what does the word of mean? What operation? No. Of means multiply. You might want to make a note of that. Of means multiply. Always, always, always. Of means multiply. Of, multiply. Of, multiply. 1/3 of the pages. Our pages was X. The second week, she read 171 pages and finished the book. Write an equation that represents the total number of pages in the book. So the total number of pages in the book is equal to what she read. So let's take what she read. She read 5 minus 1/3 x plus 171. Total number of pages in the book that she read 5 minus 1/3 x. Oh no, I did that wrong, didn't I? Oh, that's not what I wanted. What did I forget to do? I forgot to switch them. Very good. So 1/3 x minus 5. She read the first week, and she read this the second week. That's why I added them. She read something one week, something the next week. We put them together. So, I'm not finished here. What do I still have to do? Simplify. Thank you. Now, I want to combine my like terms on the same side of the equal sign. So over here, I have constants that are alike. So I have x is equal to 1/3 x. Now, what is negative 5 and 171? You guys have a calculator. Put it to use.
66.
So plus 166. So that is our equation. Now we're not solving our equations. We are just working with them. All right, let's take a look at our next page. Oh, and we have our problem set. So this is where right now, what I want you to do right now is I want you to work with a partner to do numbers 1 and 2. I would like for you to do numbers 1 and 2 with your partner, please. Yes. What? Yeah, in just a minute. Right now, 1 and 2 with your partner.
All right, partner.
Dang, Travis's partner is better than mine. Oh man, I just showed my face by accident.
Tyrone.
Right, with a partner, I need you to work 1 and 2. Would you like to come work with Brianna in the front? Lana?
Stop answering.
One book costs $4 more than 3 times the other. How do we write 3 times the other? I just want you to concentrate on 3 times the other. How do we write that? 3 times 3 is the other. So the other we don't know how to do. So 3x. 4 more than 3x. I've got to write 4 more than 3x. 4 than. It has more than. It has the word than. What does the word than tell us? It's 1 places.
I knew the words. It was just the supreme.
Okay, so that's 1 book. Do we know what the other book costs? No. So it's going to cost us the x
Quiz myself.
plus x.
Because now I probably know more.
So together, that means equals the book cost $270. So equals 72.
Oh, yeah.
Find your like terms.
Ornate.
Find your like terms. 3x and x. So let me educate you. 3x and x. I have 3 here and I have 1 there. How many do I have?
Only 2.
Very good. Next one.
Even though I can't see.
You need glasses. I mean, then put in your contacts.
All right, so let's come back together. And I want to know what you guys did. So the first one, it said Bruce bought 2 books. 1 book cost $4 more than 3 times the other. So $4 more than 3 times the other. So to write that properly, it is 3x plus 4. Together, the 2 books cost them $72. Well, this is 1 book. So I said the other book was 3 times the other, so it's just x. That equals 72. So when I simplify this, it becomes 4x plus 4 equals 72. Now, if I look at number 2, Janet is 3 years older than her sister Julie. Janet is 3 years older than her sister Julie. Janet's brother is 8 years younger than their sister Julie. Janet's brother is 8 years younger than their sister Julie. The sum of all of their ages is 55. So let's start with Janet. Janet is 3 years older than her sister Julie. That's Janet's age. Janet's brother is 8 years younger than their sister Julie. Julie minus 8. And then, of course, we have Julie's age. And the sum of all of them together is 55. So if I want to simplify this, how many x's do I have?
1, 2, 3.
3 x's. What are my constants on the left side of my equal sign? 3 and 8. So when we simplify those, what do we get? When we combine 3 and negative 8, what do we get? Negative 5. That equals 55. Now, I want you to do number 3 by yourself. I want you to do number 3 by yourself. If you're having trouble with consecutive integers, go back to the very first problem we did. So let's see if you got number 3. So I saw on some of your papers you did exactly what I did the first time. You put 3 blanks because we are talking about 3 integers. And their sum is 1,623. So the first integer, the sum of 3 consecutive integers. So what's an example of 3 consecutive integers? 4, 5, 6, 1, 2, 3, 8, 9, 10, 12, 13, 14. So my first integer is always going to be represented by x. To go from the number 4 to the number 5, what do I add to 4 to give me 5? 1. So my second one is x plus 1. And my third one, what is that one going to be? X plus 2. Thank you. So now I want to combine some like terms and simplify. So we have 1, 2, 3 x's. Please stop your personal conversations. I have 3 x's and I have 1 and 2. So I have 3 as my constant. And that equals 1, 6, 2, 3. So this is my equation. So let's look at the next one. We're going to do one more by yourself. Look at number 4. One number is 6 more than another number. The sum of their squares is 90. So I want you to think about that. Think about what you know. Think about what we've done in the past. Maybe with something with squares in them when we added squares of numbers and got a sum. What was it, that thing that we called it, that when we added two squares? What was that theorem called where we squared numbers? Pythagorean theorem. So it needs to look similar to the Pythagorean theorem. So I want you to do number 4. One number is 6 more than another number. So find what that other number is. Define what that other number is. What is that other number? What? Okay, we're just sitting there. If we're not doing what we should, you are wasting your time and mine. So we need to get something down. How do we define a number? What do we use to define a number? Any number. X, that is your number. Define it. One number is 6 more than another number. You know that one number. Here's a number. We know that it is 6 more than another number. And we know the other number as just X. We know the sum means add, of their squares. So we are going to take this first one and square it. Take this second one and square it. And we get 90. So for us to write this appropriately, it is x plus 6 squared plus x squared equals 90. That should remind you of the Pythagorean theorem because that's what it looked like. Tonight for homework, I want you to do 5, 6, 7, and 8. I want you to do 5, 6, 7, and 8. Oh, and 9 is the last one there. Do 9 as well. All right. Let's go to the next page. All right. So let's talk about the terms linear and nonlinear. So yes, you need your notebooks as well, because we need to have a discussion about the term linear versus nonlinear. What does the term linear mean? It has it in the word. What does linear mean? Line, thank you. Linear is a line. A linear equation forms 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 a line. So guess what a nonlinear equation does? It doesn't form a line. A nonlinear equation does not form a line. A nonlinear equation does not form a line. So to give you a few examples of linear versus nonlinear. Nonlinear has things like x squared. Nonlinear also has numbers divided by x. Nonlinear has x cubed. Basically, nonlinear has x raised to any power that's not 1. I think that's all you need for this in 8th grade for nonlinear. So let's think about our first example. Our first example says the sum of a number and 4 times the number. So I want you to take, God bless you, I want you to take this expression here and I want to write it using numbers. So if I take the sum of a number and 4 times the number, so that means the sum of a number and 4 times the number. So I simplify this and I get 5x. So in 5x, I want to determine if the expression 5x, if it's linear or nonlinear. So I've already told you that nonlinear has numbers that has x's that are raised to a power other than 1, is one stipulation. So what is x raised to the power of in here? 1. So is it greater than 1? Is it squared or cubed? To the power of 10? No, it's to the power of 1. So far, it's linear. Is it a denominator? Is it a number divided by x? Is x the denominator? No. So far, it is linear. Those are our two situations. So right now, x is linear. X is linear. So this equation is linear. So I'm going to look at number 2. It says the product of 5 and a number. So can someone tell me what does the product of 5 and a number look like written in numbers? As a mathematical expression, not in words. The product of 5 and a number. What does that look like? 5 times x or just 5x? So we've already said that 5x was linear. All right, number 3. Now, number 3 says to multiply 6 with the reciprocal of the quotient of a number and 7. So the quotient of a number and 7. But I want the reciprocal of that. So what is the reciprocal of x divided by 7? 7 divided by x. So it wants me to multiply 6 and 7 divided by x. So that gives me 42x. 42x. I want to know, is that linear or nonlinear? I gave you 2 stipulations to determine if it was linear or nonlinear. What is your power of x in this problem? What is the power of x in this problem? Is there a power written?
No.
So what is the power? 1. Why do I have to ask 6 times for one simple answer? So again, what is the power of x?
1.
So does that determine whether or not this is linear or nonlinear? No. Look at your next stipulation. Is x the denominator? Brianna says yes. Who agrees with Brianna that x is the denominator? Some of you are not even participating. I want to know, how is x the denominator?
Yes.
What's the difference between a numerator and a denominator? Numerators on the top, denominators on the bottom. So is x the denominator? Yes. That makes this expression, what kind of expression? Is it linear or nonlinear? Nonlinear. Okay, number 4. It says twice a number, subtract it from 4 times a number. Twice a number, subtract it from 4 times a number, add it to 15. So I'm taking twice a number and subtracting it from 4 times a number. So 4x minus 2x, add it to 15, plus 15. So when I simplify this, I get 2x plus 15. So let me ask you, what is the power of x in this expression? 1. Is x a denominator? No. That makes this expression what kind of expression? Linear. Thank you. I want you to do number 5. I want you to do number 5 with your partner, with your shoulder partner, number 5. Says the square of the sum of 6 and a number. The square of the sum of 6 and a number. The square of the sum of 6 and a number. The sum of the square of 6 and a number. So before I can do anything, I need to find the sum of 6 and a number. How do I write the sum of 6 and a number? 6 plus x. And how do I show the square of that? So if we were to to use the distributive property here, and we were to say 6 plus x times 6 plus x. I don't think we've done this in this class yet, have we? No. Okay. But what is 6 times 6? What is 6 times x? What is x times 6? What is x times x? Squared. So we really have x squared plus 12x plus 36. So this is our expression. What kind of expression is it? Really? Why is it non? Because x is raised to the square. Good. So let's look at number 6. It says the cube of a positive number divided by the square of the same positive number. So I'm going to help you with this one. So cube tells me I'm raising to what power? 3. So the cube of a positive number divided by the square of the same positive number. So x cubed divided by x squared. So far, what kind of number do you think this is? Or expression. You think it's what? Nonlinear. Okay, but let's actually work it out. If I have the same bases and I'm dividing, what do I do to the powers? Subtract. So x to the power of 3 minus 2 leaves me with, what kind of expression is it? Linear. All right. So on the next page, I would like for you and you by yourself to do number 7 and 8. I'm going to give you just 2 minutes to do number 7 and 8, please. Number 7 and 8, please. Think about 4 consecutive numbers. What does that look like? Tyron drew 4 blanks. That's a great place to start. Tiffany drew her blanks and she filled them in. Taylor drew her blanks, filled them in. Good. Or do we have equal signs in any of the things we did today?
Yes.
I'm sorry, in the last few things in this lesson. Did we put equal signs? No. So if you have an equal something, take that off. Does not equal a thing. You got about a minute left. Nakia wrote that little key with that consecutive integers. She wrote her example to be able to figure out the rest. problems? Yes? Is that what you're telling me? Quickly. Guys, we should not be struggling writing 4 consecutive integers. What is my first integer? X. Now, it doesn't say consecutive even or consecutive odd, so to get to my next one, what do I add to x? X plus 1, what do I add to this third number?
2,
X plus 2, what do I add to this one?
3,
Okay, this is not that difficult, but I see blanks on people's papers. So now how many x's do I have? 4 x's. What do my constants add up to? 6. This is my term, my expression. So is that linear or nonlinear? Linear. So number 8. So on number 8 it said 4 subtracted from the reciprocal of a number. So if I'm talking about a number, say x. What is the reciprocal of x? 1 over x. Very good. And I need to take 4 from that. This is my expression. Is that linear or nonlinear? Nonlinear. Why? Because x is the denominator. Very good. Look at number 9. It says half of the product of a number multiplied by itself 3 times. So I'm multiplying a number 3 times. And I want to find half of that. Oops, not 3. Half. Try half. Half of that. So this is x cubed divided by 2. Is that linear or nonlinear? Nonlinear. Look at number 10. The sum that shows how many pages Maria read if she read 45 pages of a book yesterday and 2/3 of the remaining pages today. So is that linear or nonlinear? Nonlinear. Really? Why non? Is x raised to a power? It's raised to the power of 1, so that doesn't matter. Is it the denominator? No, that means it's what kind of expression? Linear. All right, number 11. An admission fee of $10 plus an additional $2 per game. So $10 plus an additional $2 per game. What kind of expression is that? Linear. Number 12. 5 more than 4 times a number, then twice that sum. So 4x plus 5, all multiplied times 2. If I distribute this 2 to 4x, I have 8x plus what? 10. Linear or non? Linear. Good job. Next page is your homework. On this page, I need you to do numbers for tonight. It's about that time. We need to do numbers 1, 3, 5. 1, 3, 5, 7, 9. 7 and 9, yeah. 5 problems.